Hi everyone. In our last session, we talked about how raw data becomes meaningful information. So today, we are going to take that meaningful information and look the usual skeleton we use to hold it together. If we want to build a system that manages a school or a business, we can just toss data into a void. We need a structure. In the world of DBMS, that structure starts with the table. Think of a table as a grid. It is where we store data in a way that makes sense, using rows and columns. Now, let's look at a single horizontal row. In our notes, we see 101, Amit, and 85. So, we call this a record or a tuple. This is a single and complete unit of data. It represents one specific student. If you have 50 students in a class, your table will have 50 records. But what about these vertical columns? So these is our fields, also known as attributes. And these are the categories. Student ID, name, marks. These are attributes. They define what kind of data we are allowed to store in that column. You would not put a name in the marks field, right? So that's the power of attributes. They give our records a definition. So the next part is crucial for your exams and your logic. There is a big difference between design and data. So the first one is schema. This is your blueprint. It is a logical design. When I say a student must have an ID, a name and a grade, I am defining the schema. It doesn't change often. And the instance, this is a snapshot of the data at a specific moment. If I add a new student, Amit, to the list right now, the data has changed. That current picture of the table is an instance. Think of it like a house. So the architectural drawing is a schema, and the people living in this house right now are the instance. Now, how do we keep this organized without getting confused? So we use keys. So our first key is a primary key. This is a unique identifier, just like your thumbprint or your passport number or your driving license number. So a primary key like student ID ensures that even if we have 5 students named Amit, the system knows exactly which one is which. It must be unique and it cannot be empty. And our second key is the foreign key. This is how we create relationships. If we have a department ID in our student table that links back to a department table, that's a foreign key. So basically, it is the bridge that allows two separate tables to talk to each other. So now you might ask, why can't I just use a simple text file or a folder on my desktop? So before DBMS, we used traditional file systems and they were a nightmare. Why? Because traditional file systems had many issues. Number one is redundancy. You might have the same student's address saved in the fees file and the library file. That's a waste of space, right? So it's a redundancy. And number two is data inconsistency. If that student moves and you only update the fees file, your data is now wrong. One file says one thing and other one says another. And number three is difficult data access. And number four is security problems. So in a regular file, it is very hard to say the clerk can see the address, but only the principal can see the grades. So we have some advantages of DBMS. So number one is the reduced data redundancy. So we store a piece of data in one place. And number two is improved data consistency because it is in one place. When you update it, it's updated everywhere instantly. And number three, so the system ensures the data is correct. It wouldn't let you put a letter in a phone number field. So it was the data integrity. And the next is security and multi-user access. So it allows many people to work at once, like 100 people booking train tickets at the same time without the system crashing or double booking a seat. And the next is backup and recovery. So if the power goes out, the DBMS has logs to ensure the data is not lost or corrupted. So before we wrap up today, I want you to think about this. If I change the marks of a student from 85 to 90, did I change the schema or the instance? And why is it important that every student has a primary key? Write your answers in the comment section. Thank you.